Let us look at Cauchy's root test for figuring out the convergence of a series. Now, remember Rabe's test? We had this, let the series use some n be a series of positive terms and limit as n goes to infinity of n times u sub n by u sub n plus 1 minus 1 equal to L. Then if L is less than 1, the series is divergent. L is greater than 1, the series is convergent. But when L is equal to 1, then the test is inconclusive. So this is where Cauchy's root test comes into picture. So when L equal to 1, Rabe's test fails. Then we come to Cauchy's root test. So in Rabe's test, when L equal to 1, the test is inconclusive. Cauchy's root test can be taken as an alternate path to investigate convergence divergence. Basically, the Cauchy's root test slows down the sequence. That is, reduces the sequence to its exponential scale just enough to reveal what really matters by incorporating the nth root. So what does Cauchy's root test say? Let the series u sub n be a series of positive terms and the limit as n goes to infinity of u sub n to the power of 1 by n is equal to L. Then if L is less than 1, the series is convergent. If L is greater than 1, then the series is divergent. And if L is equal to 1, then that test fails. So here also you have a condition where Cauchy's root test is also unable to determine convergence. So now here be very careful between Rabe's test and Cauchy's root test. Because here when L is less than 1, the series is divergent. Whereas in Cauchy's root test, when L is less than 1, the series is convergent. So it's opposite. So you have to be careful. Also, the expression on which we are taking the limits are also different. So limit as n goes to infinity of u sub n to the power of n 1 by n is equal to L. For all epsilon greater than 0, there exists m in the natural numbers such that the distance from the limit to this term is less than epsilon eventually. Now this can be written as L minus epsilon is less than u sub n to the power of 1 by n, which is in turn less than L plus epsilon for all n greater than m. So for all sufficiently large n, u sub n to the power of 1 by n is between L minus epsilon and L plus epsilon. So now let's look at the different cases. Case 1, the limit is less than 1. Then what happens? We choose epsilon greater than 0 sufficiently small such that L plus epsilon is less than 1. Let L plus epsilon be equal to R, which implies R is less than 1. Then for all sufficiently large n, u sub n to the power of 1 by n is less than L plus epsilon. So, which means u sub n to the power of 1 by n is less than R because L plus epsilon is R. Now let's take the power of n on both sides. The nth root gets cancelled with the nth power. And we have u sub n is less than R to the power of n. Now, do you recognize R to the power of n? R to the power of n is a geometric series with common ratio R less than 1. Therefore, the geometric series is convergent. And since every term of u sub n is less than the corresponding term of the geometric series, that means the series U sub n is also convergent. That was our first case when L is less than 1. Now let's look at the case when L is greater than 1. So we again choose epsilon greater than 0 sufficiently small such that L minus epsilon is greater than 1. Let L minus epsilon be equal to R. Therefore, R is greater than 1. U sub n to the power of 1 by n is greater than L minus epsilon. Reversing this, we get this. L minus epsilon is nothing but R. So, U sub n to the power of 1 by n is greater than R, which implies by taking the nth power on both sides, we get U sub n is greater than R to the power of n. Since R is greater than 1, R to the power of n is divergent. And U sub n is greater than every term of the sequence R to the power of n. So, which means U sub n does not go to 0, which implies the necessary condition of convergence is not satisfied. So, since the necessary condition itself is not satisfied, we can say that the series is divergent. Now, the third case, when L equal to 1. Now, when L equal to 1, the root test cannot compare U sub n with any geometric sequence R to the power of n with R not equal to 1, and therefore provides no information about convergence. So, Cauchy's test is inconclusive when L is equal to 1. Now, let's look at an example. So, here we have a weird looking series. We have series U sub n is equal to 2 by 1 square minus 2 by 1 to the power of minus 1 plus 3 by 2 to the power of 3 minus 3 by 2 to the power of minus 2 and so on. Now, first step is always to figure out the nth term. So, let's look at this. This is the third term. First term, second term, third term. So, here n is 3. Here it is 4 and 4. So, we have n plus 1 to the power of n plus 1. And in the denominator, we have n to the power of n plus 1. That is 3 to the power of 4. So, since both are 4, we have taken it out. And here we have minus n plus 1 by n. And to the power of minus n. So, that's how we got the nth term. Now, take the nth root of U sub n. We get U sub n to the power of 1 by n is equal to n plus 1 by n to the power of n times n plus 1 by n minus n plus 1 by n to the power of minus n times 1 by n. So basically here multiple steps I have carried out. I have split n plus 1 to the power of n plus 1 as n plus 1 to the power of n times n plus 1. And in the denominator, we have n to the power of n plus 1 being split into n to the power of n times n. This remains as it is. Now here, minus n times 1 by n gives us minus 1. Now we are taking the limit of U sub n to the power of 1 by n as n goes to infinity. So limit on the right hand side as well. Now do you remember this? This is the definition of E, limit as n goes to infinity. So we have E times, as n goes to infinity, this goes to 1. This goes to 1. So we have E times 1 minus 1 to the power of minus 1. Simplifying it, we get 1 by E minus 1. Now, E is 2.718 or something like that. So minus 1 gives us 1 point. So denominator is greater. That means this will be less than 1. So Since the limit is less than 1, what do we have? That the series is convergent. That was Cauchy's root test. Now, if you found this helpful, please do like, share, and subscribe. Comment suggestions are always welcome. Thanks for watching. See you in the next session. That's it for now.